Okay, so this is the concluding part of chapter 9. So again, this is MGTS. Let me just get my pen going. So this is MGTS 103, and we are looking at chapter 9 notes, which are for hypothesis testing. So in the previous video, we looked at the notes for chapter 9, and in this video we will be looking at some of these questions from the book. So I will be solving these questions. So let's start with question number 3. It says a production line operation is designed with laundry detergent to a mean weight of 32 ounces. A sample of cartons is periodically selected and weighed to determine whether underfilling or overfilling is occurring. Whether underfilling or overfilling is occurring. If the sample data lead to a conclusion of underfilling or overfilling, the production line will be shut down and adjusted to obtain proper filling. So note that we are not given any direction here. We're just told underfilling or overfilling. So part A is formulate the null and the alternate hypothesis. That will help in deciding whether to shut down and adjust the production line. Comment on the conclusion and the decision when H naught cannot be rejected. And then comment on the conclusion and the decision when H naught can be rejected. So let's write down the null and the alternate. So remember, we are not given any direction. So mu is equal to 32 is the null hypothesis, and mu is not equal to 32 ounces is the alternate hypothesis. And that's a two-tailed test, right? That's a two-tailed test. So that was part A. Part B, if we cannot reject null, right? If we cannot reject null, that means the implication is that production line is working well, right? We don't need to do anything about it. And if we reject null, if we reject null, right, that means that the average weight is not 32 ounces. So that means production line needs to be adjusted. Okay, let's move to the next question. Carpetland salespersons average $8,000 per week in sales. Steve Contois, the firm's vice president, proposes a compensation plan with new selling incentives. Steve hopes that the results of the trial selling period will enable him to conclude that the compensation plan increases the average sales per salesperson. Right? Part A is develop the appropriate null and the alternate hypothesis. Part B, what is type 1 error in this situation? What are the consequences of making this error? Part C, what is a type 2 error in this situation and what are the consequences of making this error? So let's start with part A. Remember what Steve is saying. Steve hopes the result of a trial selling period will enable him to conclude that the compensation plan increases the sales. So sorry. So the new sales plan increases sales, right? More than $8,000. And so the null is mu is less than equal to $8,000, right? And this is a one-tailed test. Okay, now what's a type 1 error? A type 1 error is incorrectly rejecting null hypothesis, right? When we incorrectly reject the null hypothesis, that is type 1 error. So if we incorrectly reject the null hypothesis, we think, and we will say, oh, the alternate plan works really well, or we will say, yes, the new plan really works, and we'll implement a new plan even though it doesn't work, right? So the outcome is that we will implement the new sales plan even though it doesn't work. Okay, part C, what if you make a type 2 error? So type 2 error is not rejecting null when we should have, right? So we should have rejected the null, but we did not reject the null. So what is the implication? Implication is we do not implement the new sales plan even though it is effective, which in other words means loss of potential revenue for the company, right? Okay, so let's go to next question. Question 11 is straightforward. We are given a two-tailed test. So it's a two-tailed test. Null is mu is equal to 15. Alternate is mu is not equal to 15. So this is a two-tailed test. And a sample of 50. So n is 50. Provided a sample mean of 14.15. X bar is 14.15. The population standard deviation is 3. So we're going to use the Z table. And then we just do the p-value approach and the critical value approach to solve the question. So let's do it. So Z is equal to X bar minus mu over sigma divided by square root of n. Now X bar is equal to 14.15, mu is 15, sigma is 3, and n is 50. Okay, so this is equal to 14.15 minus 15 divided by sigma is 3 divided by square root of 50. So this comes to -2. Okay, now what's the p-value? Remember, it's a two-tailed test. So in a two-tailed test, p-value is going to be double the probability. Okay, so let's calculate. So if this is -2, then this area is 0.0228. So the p-value is twice 0.0228. Remember, -2 was the calculated z value, right? And so the p-value is 0.0456 and alpha is 0.05. Okay, and because our p-value is less than equal to alpha, we reject null. Okay, so that was the p-value approach. So that was part A, B, and C. And let's do part D, the critical value approach. Of course, we know that the result should be the same even if you use the critical value approach. Okay, so alpha is 0.05 and it's a two-tailed test. So alpha by 2 is 0.025. Okay, if this is 0.025, then z is 1.96. Okay, we reject null if absolute value of Z calculated is more than equal to absolute value of Z alpha by 2 from the table. So our calculated value was -2. Let's take the absolute value and compare it with 1.96, the value from the table. So absolute value of -2 is 2. Absolute value of 1.96 is 1.96. So our calculated value is more than the value from the table. The same result, reject the null hypothesis. Okay. Let's go to question number 13. Consider the following hypothesis test. Mu is less than or equal to 50, and alternate is mu is more than 50, so it's a one-tailed test. One-tailed test. A sample of 60 is used, so n is 60, and the population standard deviation is 8, so sigma is 8. We're going to use the z table. Use the critical value approach to state your conclusion for each of the following sample results. So we are given different x bar values, and alpha is 0.05. So let's do part A first. So in part A, of course, z is x bar minus mu over sigma divided by square root of n. Okay, and we are going to use the critical value approach. So it's a one-tailed test and alpha is 0.05. So if this is 0.05, then Z alpha from the table is going to be 1.645, right? Let me just give me 1 second, please. Just want to double check something here on my notes here. So I'm just looking up something. Give me a second here. Yeah. Okay. Yeah. So sorry about that. Okay, so yes, so the alpha is 0.05 and therefore, and it's a one-tailed test, and so the Z alpha is 1.645. Okay, so remember we will reject null in each case if absolute value of Z calculated is more than equal to absolute value of Z alpha from table, which happens to be 1.645. Okay, so in part A, Z is equal to 52.5 minus 50 divided by 8 divided by square root of 60, which comes to 2.42. So absolute value of 2.42 is 2.42, and this is more than equal to 1.645. So we can reject null. Okay, so why don't you guys do part B and C on your own? Okay, so basically in part B, your Z calculated is going to be different than part A, and it should come to 0.97, and in part C, your Z calculated should come to 1.74. So see whether you can reject the null or not reject the null in each of the two cases, and you can compare your answers with the answers that are posted on Blackboard. Okay. Basically, in each of the cases, you compare your calculated value with the value from the table. Okay, let's do question number 15. Individuals filing federal income tax returns prior to March 31st received an average refund of $1,056. Consider a population of last minute filers who mail their tax returns during the last 5 days of the income tax period, typically April 10th to April 15th. A researcher suggests that a reason individuals wait till until the last 5 days is that on average these individuals receive lower refunds than do early filers. Develop appropriate hypotheses such that rejection of null will support the researcher's contention. So a researcher suggests that individuals who file late receive lower refunds. So the word is lower, so that's giving us a direction, right? So individuals who file late, 1056 is the average. Individuals who file late receive lower refunds. And then the null is mu more than equal to 1056, and this is a one-tailed test. Okay, so that was so this is a one-tailed test. Okay, so for a so part B, this was part A. Part B, for a sample of 400 individuals who filed a tax return between April 10th and 15th, basically who were late filers, the sample mean refund was $910. So X bar is $910. Wow. So it seems that people, so this was like olden times when people were kind of mailing their taxes and not really filing them online, and maybe by the end the CRA was just getting overwhelmed with a lot of filings, and it seems that people who were filing late were getting lower refunds. So the X bar was let's say for this sample is $910 based on prior experience of population standard deviation of sigma equals to $1,600. So we'll use the Z table. And so they're saying what is the p-value? Okay, it's a one-tailed test, right? Okay, so let's calculate the Z first. Z is X bar minus mu over sigma divided by square root of n. X bar is $910, sigma is 1600, mu is 1056, and n, the sample size, is 400. So we plug in the numbers here. 910 minus 1056 divided by 1600 divided by square root of 400, and if you solve this it comes to negative 1.83. Okay, I'm just going to go to the next page to solve it. Okay, yeah, so our Z calculated comes to negative 1.83, and it's a one-tailed test. So if this is negative 1.83 as a Z-score, then this area comes to 0.0336. So the p-value, which is in this case one times the probability because of one-tailed test, comes to 0.0336. Okay, now in the question, let's just go back to the question. Alpha is 0.05. Okay, so alpha is equal to 0.05. So our p-value is less than equal to alpha, so that means we can reject null, which means late filers receive significantly lower refunds, right? Which is kind of interesting. It seems that people who are filing late were receiving lower refunds than average. Okay, now let's solve this question using the critical value approach. So alpha is 0.05. It's a one-tailed test. So if this is 0.05, then z is equal to 1.645, and we reject null if absolute value of z calculated is more than equal to absolute value of z alpha from table. So negative 1.83 versus 1.645. Absolute value of negative 1.83 is 1.83 versus 1.645. So 1.83 is more than equal to 1.645. So again, the same result, reject null, right? So the result is the same. Okay, so the result doesn't change. Now, remember, one thing I wanted to share with you was that what if you didn't use the critical value approach? Well, then you have to remember that when we formulated the null hypothesis, the alternate hypothesis gives us a lower tail test. Okay, so it's a lower tail test, and in a lower tail test, you reject null if your z calculated is less than equal to z alpha by 2, negative z alpha by 2. So z calculated is negative 1.83, and negative 1 z alpha by 2 is 1, sorry, z alpha, apologize here. It's a one-tail test, so it should be negative z alpha. So that is 1.645, so negative 1.645. So 1.83 is lower, less than equal to negative 1.685. Excuse me. Yeah. So negative 1.83 is less than equal to negative 1.645, and so you would, excuse me, reject null. Right. So the result is the same whether you follow the absolute using absolute values, or using whether you are on the lower tail or the upper tail. Okay, you will get the same result. You would need to solve a few questions on your own to make sure that you're not that you understand this material, because sometimes because of these rules there can be some confusion. So I do suggest that you please try these questions by yourself, and I'm also going to suggest some questions from the end of the book, from the end of the chapter, that you can try, and the answers are all already provided on the blackboard. Okay, so now let's do a two-tailed test. Consider the following hypothesis test. Null is mu is equal to 100, and alternate is mu is not equal to 100, and it's a two-tailed test. A sample of 65, so n is 65, is used. Identify the p-value and state your conclusion for each of the following sample results. Use alpha 0.05, and in each of the examples we have a different x bar and a different sample standard deviation. Because we have sample standard deviation, we are going to use t with n minus 1 degrees of freedom, that is 64 degrees of freedom. Okay, so let me do part A, and then you can do parts B and C on your own, and we're going to use the p-value approach. So t is equal to x bar minus mu over s divided by square root of n. In the first example, x bar, the sample mean is 103. Let me rewrite it. So x bar is 103, s is 11.5, and n, as we know, is 65. So this is equal to 103 minus 100 divided by 11.5 divided by square root of 65. Okay, and it comes to 2.10. Now we know that it's a two-tailed test, so p-value is going to be twice the probability. Okay, now if t is 2.10, then this area, okay, is Okay, so if you look up so just go to the T table, and I'm also looking up the T table right now for 64 degrees of freedom. You will find that 2.10 for 64 degrees of freedom, 2.10. So 2.10 is between 1.998 and 2.386. Okay, so 2.10, the calculated t value is between 1.998 and 2.386, and therefore the probability is between 0.025 and 0.01. Okay, so this area is between 0.025 and 0.01. So if we multiply it with 2, then p-value is between 0.05 and 0.02, right? Because if you multiply 0.025 with 2, then we get 0.05, and multiply 0.01 with 2, we get 0.02, and alpha is 0.05. Okay, now if you look at this interval, this entire interval, all the values including the end interval, so end value of the interval, you will see it's either equal to alpha or less than equal to alpha, right? So 0.05 is equal to alpha, and rest everything else is less than alpha. So this entire interval is either equal to or less than alpha, and therefore we can reject null in part A. Okay, so in part A we can reject the null. Now I do suggest that you do parts B and C by yourself. So in part B, what you would get is you will get a t-score of negative 2.57. It's a two-tailed test, and you will get a p-value between 0.01 and 0.02. So see if when you compare it with alpha of 0.05, what's your result? And again, you can look up the answers on Blackboard. In part C, your calculated t-score should come to 1.54. Okay, and your p-value will be between 0.10 and 0.20, and when you compare it with alpha equals 0.05, see what's your inference. Okay, so for both of these parts you can look up the answers on Blackboard and see what do you get. Okay, let's do the last question, question 31, that I would like to do with you. Chocolate consumption. The US ranks 9th in the world in per capita chocolate consumption. Excuse me. So the US ranks 9th in the world in per capita chocolate consumption. Forbes reports that the average American eats 9.5 pounds of chocolate annually. Just get my pen going here. Okay. Suppose you're curious whether chocolate consumption is higher in Hershey, Pennsylvania, the location of Hershey Company's corporate headquarters. A sample of 36 individuals. So you're curious whether chocolate consumption is higher in Hershey. Okay, a sample of 36 individuals from the Hershey area showed a sample mean annual consumption of 10.05 pounds and a standard deviation of S equal to 1.5 pounds. Using alpha 0.05, Do the sample results support the conclusion that mean annual consumption of chocolate is higher in Hershey than it is throughout the US? Okay, so let's formulate the null and the alternate first. And the average consumption in the US is 9.5. Now, it is saying you want to test whether chocolate consumption is higher in Hershey. So chocolate consumption is higher in Hershey. And then the null is mu is less than or equal to 9.5, and it's a one-tailed test. And because we are given a sample standard deviation 1.5 pounds, we will use T with n minus 1 degrees of freedom. So n is equal to 36, so with 35 degrees of freedom. Okay, let's calculate the T. T is x bar minus mu over s divided by square root of n. X bar, the consumption, the sample consumption, average consumption in your sample is 10.05 in Hershey. Mu is equal to 9.5. S, the sample standard deviation is 1.5, and n is equal to 36 people. So this is equal to 10.05 minus 9.5 divided by 1.5 divided by square root of 36. And when you solve this, you get 2.20. Okay, so if this is 2.20, then this area comes to between 0.01 and 0.025, right? Because for 35 degrees of freedom, T value of 2.20. So I'm just pulling up my tables on the other window. So for 35 degrees of freedom, 2.20 is between 2.03 and 2.438. So that means that the p-value is between, or the probability is between 0.025 and 0.01, right? And since it's a one-tailed test, so p-value is 1 times the probability, which means it is between 0.025 and 0.01, and alpha that is given in this question is 0.05. So if you look at the entire interval is less than, I'm just saying equal to, but it's actually, so the entire interval is less than the alpha value. So yeah, so p-value is between 0.025 and 0.01. Alpha is 0.05. So the entire interval is less than alpha. We can reject null. And if we, so remember what was our null? Our null was that mu is less than or equal to 9.5. And so if we reject the null, it means that chocolate consumption is higher in Hershey, right? So the chocolate consumption is higher in Hershey than rest of US, which makes sense because Hershey is the headquarters, so maybe people are kind of more loyal there, or maybe Hershey has more kind of promotions going on in the area. Who knows? Okay, let's do the same question using critical value approach. So alpha is equal to 0.05, right? Alpha is 0.05 and 35 degrees of freedom. So T is 1.690 and we reject null if absolute value of t calculated is more than equal to absolute value of t alpha from table. So our calculated value was 2.20 versus the value from the table, or the critical value is 1.690. So 2.20 is more than equal to 1.690 and the result is the same. We can reject null, which means yes, the average chocolate consumption in Hershey is higher than rest of the US. So the result is the same. Okay, so with that, we come to the end of the question that I wanted to do with you. And as I suggested at the beginning, kindly try some additional questions from the book, and the answers are already provided for you on Blackboard. Okay, thanks.